Good morning, all of you. Now we are going to start examples on moment of forces, and after that, examples on coplanar non-concurrent forces. So we know that what is moment and how we can get the moment of force for the particular cases. Let's start here. First example, capital ABCD is a square of 5 meter, side forces of 100 kilonewton, 250 kilonewton, 150 and 300 kilonewton are acting along BA, DA, DC and BC respectively. Find the algebraic sum of the moments of all the forces about the center point of the square. Write capital ABCD on the square in a clockwise sense, means this is our square having 5 meter sides. Capital A, B, C, D in clockwise pattern. First, our force is 100 kilonewton, which is acting along B to A, means B to A 100 kilonewton. Second, force 250 kilonewton, it is acting D to A, means D to A, force somewhere over here. Third one is our 150 kilonewton, it is acting D to C. From D to C it is 150, and last one is 300 kilonewton, which is B to C, from B to C. So this is our forces. We are going to finding out the moment of all the forces about the center point. So the distance from the forces towards the center is 2.5 meter from all of the forces. Now what we are going to do, we have to find out moment of all forces about C points, means this is our 250 kilonewton force is moving towards the upward direction, so it will create clockwise moment. So here 250 into 2.5, this 100 kilonewton force is moving leftward, means it is moving somewhere over here, so it will create anti-clockwise moment. This is 300 kilonewton, it is going to clockwise, and again 150 kilonewton is acting anti-clockwise. So here we have to understand the proper position and rotation of our clock, then and then we can understand how the moment become clockwise and anti-clockwise. So moment about the center of square, what is happening, this 100 kilonewton force is anti-clockwise, this 250 kilonewton force is clockwise. So first of all, moment at O is equal to 250 into 2.5, this 300 again clockwise, so it is plus 300 into 2.5, this 150 is anti-clockwise, so it is minus, and this is 100 again anti-clockwise, so it is minus. So the algebraic sum of all the moments is 750 kilonewton into meter. It is, we will get, it is positive, means the whole sum of the moment is clockwise, means the direction of this moment is clockwise. Clear? Now another case, determine the sum of the moments of forces about A for the given force system. This is our force system, capital A, B, C and D, and forces are acting on this system. First, at B point it is downward 600 Newton and distance is 200 mm. B to C is 400 mm, and here the force is inclined at some slope. So first of all, we have to finding out this theta. Why we are going to finding out this theta? Because we have to always convert this force in horizontal and vertical position, and for that we know the how to resolve the force. Again here it is also inclined. So first of all, we have to finding out this resolution. So this 200 cos 30 in x direction and 200 sin 30 in y direction. For here we have to finding out the slope, and this theta is equal to tan theta is equal to 3 upon 4. So we will get theta is equal to 36.87 degree. So here the horizontal component is 500 cos 36.87 and here 500 sin 36.87. Now we have to take moment at A. So what happening? 600 into 200, first one, 500 sin 36.87 into 600 at A. This one is not creating moment because it is acting on a point. So moment is only produced due to force into distance, but here the force is acting on the same point to A, then and then it can't create the moment. Same way, this is our vertical force, it will create anti-clockwise moment, and this is 200 cos 30 create clockwise moment. So 200 cos 30 into 200 mm and 200 sin 30 into, it is anti-clockwise. So minus, here again 500 is minus. So what happening? 600 into 200 plus 500 sin 30 into 600 plus 500 cos 30 36 into 0.87 is 0, multiplying with 0. Now 200 cos 30, that is clockwise, so it is multiply with 200 minus 500 into 200 and minus 500 sin 30 into 600. So we will get the moment at A is equal to 174,641.42 Newton into meter. So we will get here the answer is positive. So our moment is clockwise. Clear? Now find the minimum force at P required to act at a point as shown in the figure that may cause same moment at point B due to 50 kilonewton force. Understand this figure. Here A and B both point, the dimensions is given over here. The 50 kilonewton force, it will create moment at B, but we have to finding out the minimum force which creates same moment at B, then and then we can get the minimum force. So first of all we have to finding out this angle, means tan theta 1 is equal to, this is our theta 1, 10 by 35, so theta 1 is equal to 15.96 degree. Now for the P should be perpendicular to line AB, so it is minimum, we know that. So AB is equal to, the length of this AB is equal to under root of 35 square plus 10 square, then we will get the 36.40 centimeter. It's a length of AB. Now moment due to 50 kilonewton force at B is equal to 50 into 10, so we will get 500 kilonewton into mm, and moment due to force P, so P into line AB, right, and the distance of this AB line is equal to 36.40. Now we have to equalize them. So MB is equal to P into 36.40, but MB is equal to 500, so we will get P is equal to 13.74 kilonewton. Clear? Okay. Now a rectangular hexagon of 100 mm side is subjected to 10 kilonewton force as shown in the figure. Find the moment of this force about point A and about point C. So here we have only one force, but we have to consider moment of this force at C and at A. It is a regular hexagon, so the angle of this hexagon is 60 degree from outside. Now we have to convert this force in horizontal and vertical. So what we will get? 10 cos 15 and 10 sin 15. Now the most important thing, that is we must have to finding out the dimensions. So for that, this is our all right angle triangle making over here. So sin 30 is equal to AB upon 100. This dimension is 100. So Sine 30, this is 60, then this is 30. So we will get AB is equal to 50 mm, and for the cos 30 is equal to 86.60. So we have all the vertical dimension, that is 86.60, and horizontal dimension is 50 over here. But from B to this point D, B to D is equal to 100, that given over here. So at A point, what happening? The moment at A is equal to this force moving upward, so it will create anti-clockwise moment. So minus 10 sine 15 into the whole distance from A to D, that is 150, and this force create clockwise moment, that is 10 cos 15 into 86.60. So we will get the answer, that is clockwise. Clear? So this is for 8.27 clockwise moment over here. Now at C point, what happening? This force create clockwise moment, 10 cos 15 into 86.60, and this moving upward, it create anti-clockwise moment, so minus 10 sine 15 into 50 mm. C to D distance is 50 mm. So we will get the clockwise moment at C, that is 707.89 kilonewton into mm. Now these are the case of moment, but now we are going to finding out the equivalent force couple system, and we know that what is equivalent force couple system, that we have understand in our previous lecture, that is part of theory. Now let's apply how to calculate the equivalent force couple system. An angle is subjected to 30 Newton force as shown in the figure below. Replace this force as an equivalent force couple system at point A. So this force is inclined. Whenever we have this inclined force, that we must have to convert this force in horizontal and vertical direction. So here first we have to finding out this theta, and that theta we can calculate using 10 component. Now this force is directly acting on point A, but due to this distance it will create the moment. So what happening? This is two component of our inclined force, that is 24 kilonewton and 18 kilonewton. So moment at A due to this clockwise 18 into 200, and this is anti-clockwise 24 into 300. So what happening? The tan theta is equal to 3 by 4. So theta is equal to 36.86 degree. Now component that we can calculate from this theta. Now taking moment at A, the 18 into 200, that is clockwise, and minus 24 into 300. So we will get minus 3600 kilonewton into mm. So it is anti-clockwise. Now this inclined force is applied on point A, and this equivalent force couple system is applied over here. So what happening? This is our force and this is our couple of moment. So this is called equivalent force couple system. This is force and this is couple of moment. So this is called equivalent force couple system. Clear? Now another case, replace 200 Newton force by an equivalent force couple system about point C for the system shown in below. This is our force system, and here inclined force 200 Newton at 60 degree with horizontal. So first of all we have to convert this force in horizontal and vertical. So we will get two component in x direction, that is 100 Newton, and in y direction, that is 173.20 Newton. Now moment at C, what happening? Due to this force, it is clockwise moment, 173.20 into 20, and this is towards the right, means it also create clockwise moment, 100 into vertical distance 40. So moment at C, we will get 7464 Newton into centimeter. So what happening? This force is directly move at C point, in the same pattern incline, and we will get the moment from this, it is clockwise. So this is our couple of moment. Now this is equivalent force couple system at point C. Clear? Now this is the most important case. Replace the forces acting on a road by an equivalent force couple system. Here in this case we have going to finding out equivalence force couple system. So that is clear. Here only one force that we have, but whenever the number of forces are acting, from that we must have to convert in this single force. So what is the procedure? That we must have to finding out the single force, and that is known as resultant force. So from these four forces, first of all we must have to finding out the sigma h and sigma v. What happening? Sigma h means from these forces, it is horizontal leftward, this is downward. So we will get the resultant force in third quadrant, and that is 553.55, and here vertical 1053.55. So what happening? The resultant force is getting 1190.12 Newton, and the angle we will get, that is 62.28 degree. Now the moment from all the forces at a point, that is 700 into 0.5 plus 500 sine 45 into 1 plus 500 cos 45 into 0.4. We can't take moment due to 200 because it will acting on the point, so moment is 0. So here we will get moment at A is equal to 844.97 Newton into meter, that is clockwise. So replace all the forces by the resultant force, and this is our equivalent couple of moment. Clear? Now the most important thing, that is examples on coplanar non-concurrent forces. What is this? This is the main example of this chapter. We have number of forces acting on a system, then from that we will get the resultant force, and after that the finding out position of resultant force. So find magnitude and direction of resultant force with respect to point O for a system shown in figure. Means here from this O point we have to finding out the position of resultant force. So first of all, from these forces we have to finding out the single force, that is resultant force. So what happening? This is our inclined force. So first of all we have to convert these two force as a resultant. This is 20 and this is our, so total number of forces are acting 5 forces. Now first of all sigma h, this 10 kilonewton towards the right means it is plus, 5 kilonewton it is minus, and this is again minus 20 cos 45. So we will get sigma h is equal to minus 9.14, it is leftward. Now sigma v is equal to vertical force, these two vertical force moving upward, so it is positive 34.14 kilonewton upward. So sigma h is equal to leftward and sigma v is equal to upward. So our resultant force is acting in a second quadrant. Now the resultant R is equal to under root of sigma h square plus sigma v square, that we can know how it will get, that we have understand in our previous lecture how we will get the resultant force. So here the resultant force is 35.34 kilonewton, and the direction of this resultant, tan theta is equal to sigma v upon sigma h, so theta is equal to 35 degree. Now magnitude and direction of resultant force that we have, but we have to finding out the position of resultant force. What happening here? R is acting in a second quadrant, so it will move like in second quadrant from the O point. So we have to finding out this position of resultant force in the form of x. So to finding out the position of with respect to O, let's R be at perpendicular distance x from the O. Now using law of moments or as Varignon principle. What Varignon principle says that whenever resultant force is acting on a point O, then the moment of all other forces at point O is same. So here moment at O due to R is equal to anticlockwise R into X is equal to moment of all other forces. So what happening? These two forces can't produce moment. Again, this vertical force can't produce moment. Only horizontal force produce moment is equal to minus 20 cos 45 into 2 meter, and this 20 again anticlockwise. So these two both create anticlockwise moment. Now put the value of R that we have. So we will get x is equal to 1.932 meter from this O point. Clear? Again, the most important thing, find the magnitude and direction and position of resultant force with respect to point O for a system shown in the figure. Here this force is acting over here and the horizontal distance 4 and vertical is 0. This inclined force 5 kilonewton at 75 degree is acting at 2 meter from horizontal and 3 meter from vertical. This moment is directly acting over here, and this inclined force at 60 degree is acting at 3 meter from downward of this O point. So first of all, we have to finding out the resultant. For that we have to finding out sigma h and sigma v, and for that we must have to resolve these two inclined force in horizontal and vertical. So we will get something like this: vertical, horizontal, this is horizontal and vertical. Now we have all the forces. So from these forces we can calculate sigma h and sigma v. Sigma h is equal to minus 5 cos 75 degree leftward. Again this is minus 5 cos 60. So sigma h is equal to minus 6.29 kilonewton. So it is leftward. Now sigma v, this is downward, so minus, this is again downward, so it is minus, and this is upward. So again we will get sigma v is equal to minus 6.41, so it is downward. Now from these two we will get r and theta. Clear? R is equal to under root of sigma h square plus sigma v square. So r is equal to 8.98 kilonewton and theta is equal to 45.44 degree. So we have r means magnitude and direction, that is theta. Now the most important task, that is position of r. So first of all, r is acting in a quadrant 3 and we have r and theta. So this theta is parallel to move from the O in somewhere over here, and we can get this perpendicular distance x, that is position. So for the position of r about O, what happening? For that we have to take moment with the help of Varignon principle. So this is clockwise moment, r into x is equal to 5 cos 60 into 3, this is vertical distance 3. 20 is clockwise moment. This 5 cos 75 create anti-clockwise moment, right? When force horizontal, take distance vertical. Here clockwise moment 5 sin 75 into t. Here it is 2. Now this 6 into, again it is clockwise. So we will get the value, that is 8.98 into x is equal to 57.28. So x is equal to 6.38 meter from this O. Now we can get the position, magnitude and direction of resultant force. Clear? Okay, thank you very much.